think about how much of our lives happens online. I mean, our work, our finances, how we connect, all of it runs on these huge interconnected networks.
Absolutely.
But just like a city has weak spots, so do these digital spaces. They're constantly under threat.
Mm-hmm.
So today, we're diving into this critical world of network attacks and how cybersecurity analysts actually work to defend these systems.
Yeah, exactly. And the resources you looked at, they give a really valuable glimpse into the different attack methods and the defense strategies people use. It's fundamental stuff for anyone wanting to understand how we keep our digital world secure.
Right.
Our goal today really is to pull out the key pieces from that information, give you a clear picture of the common ways networks get breached, the kind of damage they can do, and how these things get investigated, without getting totally lost in the super technical weeds.
Okay, let's unpack that then. The info you shared kicks off with network interception attacks. Now, when I read that, it sounded pretty straightforward, like someone just sort of grabbing info floating around. What does that actually look like in practice?
That's a decent way to frame it, actually. At its core, a network interception attack is about capturing data while it's moving across a network.
Okay.
And one common technique for this is called packet sniffing. It basically uses special tools, hardware or software, to grab those little bundles of data, the packets that are always zipping around so they can be looked at.
And the danger there seems pretty obvious, doesn't it? It's not just seeing the digital equivalent of a postcard.
Precisely. It's more than just seeing it. If an attacker intercepts sensitive info, like, say, someone typing in their login details, they can steal usernames, passwords. But even worse, potentially, is actually changing data mid-transit. Imagine someone altering the amount in an online bank transfer. That's the kind of really serious impact these attacks can have.
Wow. Okay.
And the materials also mention things like on-path and replay attacks as other types of interception. We can circle back to those a bit later on.
That sounds incredibly invasive. The information also talked about backdoor attacks. That phrase kind of brings to mind someone finding a secret way into a building, Is that a fair comparison in cybersecurity?
That's an excellent analogy, actually. Just like a physical backdoor bypasses the main locks, right?
Yeah.
In cyber, backdoors are basically weaknesses. Sometimes developers intentionally leave them for troubleshooting or maintenance.
Well,
But the problem is, if attackers who've already maybe gained some access find these backdoors, they can exploit them to keep getting in. Persistent access, we call it. It's like leaving that spare key under the mat. You think only you know, but someone else finds it.
Gotcha. So once an attacker is in through this back door, what kind of damage can they actually do?
Well, once they're inside, the potential for harm is pretty significant. They could install malware, obviously. They could launch denial of service attacks, DOS attacks.
With the traffic jam analogy.
Exactly, yeah. As the info explained, it's like creating this massive gridlock, flooding a network or a server with so much junk traffic that legitimate users just can't get through.
Okay.
Attackers can also steal confidential data or even change security settings to make the system more vulnerable later on.
That paints a pretty worrying picture. So when these attacks happen, whether it's interception or a backdoor thing, what are the real world consequences? Why should someone who isn't a cyber expert care?
Oh, the impact can be felt in really tangible ways. Financially, for a start, organizations can face huge losses. Think about system downtime. They can't make money. Then there's the cost of fixing everything, potential ransom demands in ransomware cases.
All right, ransomware.
And legal fees, fines if customer data gets breached. But it's not just the money,
Reputation, too, I bet.
Definitely. Damage to reputation can be devastating. If the public finds out a company's been hit, trust just evaporates. Customers might go elsewhere.
And as the sources pointed out, it can get even more serious than money or reputation.
Right. Absolutely. When you think about attacks on government networks, the public safety implications can be dire.
Like critical infrastructure.
Exactly. Power grids, water systems, military communications. A successful hit there could have widespread, even life-threatening consequences. The key thing, really, is that malicious actors are always looking for weaknesses, and methods like backdoors and interception are major tools in their toolbox, posing these very real financial, reputational, and, yes, public safety risks.
Okay, so if there's a suspicion that an attack is happening, how do the defenders, the cybersecurity analysts, figure out what's going on? The info-mentioned tools called network protocol analyzers. What are those?
Yeah, these tools, they're also known as packet sniffers, basically. They're essential for watching the communication on a network, spotting anything weird or suspicious. The materials you saw listed several examples: SolarWinds NetFlow Traffic Analyzer, Manage Engine Not Manager, Azure Network Watcher, and the very well-known Wireshark.
And one tool that got specific focus was TCP dump. What makes that one special?
Right, TCP dump. It's a command line tool. It's lightweight, meaning it doesn't hog system resources, and it's open source, which is a big plus for many people.
Okay.
It runs on Linux, Unix, Mac OS, and it gives you this live text-based view of network packets right there in the terminal.
Okay, so if you run this command, what do you actually see? What info does it spit out about the traffic?
Essentially, yeah. TCP dump breaks down each packet as it goes by. It shows you the key details, like the example in your sources showed. You typically get a timestamp exactly when the packet was caught.
Right.
Then the source IP address and port number where it's coming from, the destination IP and port where it's going. And some flags that tell you about the packet, like a SYN flag, means it's starting a connection.
Okay.
And TCP dump tries to be a bit helpful by default, sometimes translating IPs into host names or replacing port numbers with service names, like showing HTTP instead of port 80.
So you're seeing the who, what, when, and where of network traffic, kind of in real time. How do security pros actually use that information day to day?
Oh, it's incredibly versatile. Analysts use it first to figure out what normal traffic looks like on their network. Establish a baseline.
Makes sense.
Because then it's much easier to spot unusual patterns that could signal something bad is happening. Like maybe a sudden flood of traffic to a weird port. That's a red flag. It can also detect specific kinds of malicious traffic. You can set up alerts for certain events, even help find unauthorized devices plugged into the network.
But attackers could use it too, right?
That's the crucial caveat, yes. As your sources pointed out, attackers can absolutely misuse these same kinds of tools. If data isn't encrypted, they could use sniffers like TCP dump to capture sensitive stuff like usernames and passwords. Running TCP dump gives you that fundamental packet routing info.
Right, got it. Seeing how it works in theory is one thing, but real-world examples always hit harder. The info detailed a pretty major DDoS attack from 2016, targeting DNS servers. Can you walk us through that one? What happened?
Yeah, that was a really significant event. It starkly highlighted how critical and sometimes fragile the internet's underlying infrastructure can be.
Okay.
So DNS servers, as we know, they're like the internet's phone book, right? Translating website names we type into the numerical IP addresses computers use. Well, back in 2016, a lot of major online companies relied on just one single DNS service provider, which, as the event showed, is a big risk, that centralization.
So if that one provider had issues, it could take down loads of sites.
Exactly. And that's what happened on October 21st. A massive distributed denial of service, DDoS, attack just overwhelmed this provider's systems.
How do they manage that?
Well, the backstory's kind of wild. Some university students had created a botnet, a network of hacked computers controlled by an attacker.
Right, zombie computers.
Yeah, basically. They initially made it for attacking gaming servers, but then, pretty unwisely, they posted the source code for this botnet online.
Oh boy, that sounds like a bad idea.
It was. Cybercriminals jumped on it immediately, used the publicly available code to launch this huge attack against the DNS provider.
So what was the result?
Around 7 a.m., tens of millions of DNS requests just flooded the provider's servers, completely shut them down, which meant widespread website outages across North America and Europe. Lots of popular services just became unavailable.
Wow. How long did that last?
Thankfully, the service was back up after about 2 hours, and the provider put better measures in place afterwards. But it really hammered home how damaging DDoS attacks are and why you need strong defenses.
Yeah.
Things like distributed, scalable infrastructure that can handle those crazy traffic spikes.
Yeah, really drives home the point. Now, the info you shared also mentions these things called exemplars for analyzing network communication and attacks. What are those? How do they help?
Right, the exemplars. They're essentially sample cybersecurity incident reports. Think of them as models. They show you how to look at network traffic data, like logs, and then document what you find when investigating a security event. You can find them via the links or attachments provided.
So you can compare your own work to them.
Exactly. The idea is for you, the listener, to compare your own analysis, maybe from exercises or real scenarios, to these examples. It gives you a feel for what a thorough investigation looks like, helps you spot what you're doing well, and where you could improve your analysis or reporting.
So it's like a guide or a benchmark.
Pretty much. The exemplar on network layer communication, for instance, shows one way to interpret things like DNS and ICMP logs to find potential issues with a DNS server, maybe suggesting a DOS attack. It stresses noting the protocols, detailing what the logs show, and explaining what that might mean.
It's not the only way, but a way.
Precisely. Real-world analysis varies, but the core skill is looking at that raw packet data and making informed guesses about what's happening, potentially even stopping future attacks.
That sounds like really valuable practice. Okay, let's circle back to those interception tactics we mentioned earlier. The info went into a bit more detail on those.
Yes. So, as we said, interception attacks are about grabbing data packets in transit. Packet sniffing, which we covered, is key here.
Right, using tools like Wireshark.
Exactly. It exploits how network interface cards, NICs, normally only process packets addressed to them, but you can put a NIC into promiscuous mode.
Promiscuous mode?
Yeah, it means it captures all traffic passing by, not just its own. Tools like Wireshark do this. And the danger, again, is that sniff data can contain sensitive info, IP addresses, MC addresses, which can then be used for other nasty stuff like IP spoofing.
And IP spoofing is basically pretending to be someone else online, digitally.
That's it, exactly. Faking the IP and MC address of an authorized device. It helps attackers get past security like firewalls that might block traffic from unknown IPs. Several attacks use this.
Like on-path attacks, man in the middle.
Right. In an on-path attack, the attacker sits between two trusted devices talking to each other. They intercept the data flowing back and forth, stealing usernames, passwords, or they could even manipulate DNS lookups, redirecting you to a fake website instead of the real one without you knowing.
How do you stop that?
Encryption is key. Strong encryption, like TLS. It makes the intercepted data unreadable to the attacker.
Okay. And then there are Smurf attacks. Sounds less threatening than it probably is.
Definitely not fun for the victim, despite the name. A Smurf attack combines IP spoofing with a denial-of-service technique.
How does that work?
The attacker spoofs the victim's IP address. Then they send a flood of packets, often ICMP pings, to the network's broadcast address.
The broadcast address.
Yeah, sending to that address means every device on the network responds. But because the source IP is spoofed, all those responses go hammering the victim's machine. It amplifies the traffic massively, overwhelms their server.
Ouch. Defenses?
Advanced firewalls, NGFWs with anomaly detection. They can spot and block those weird broadcast patterns.
We also talked about DOS attacks earlier. How does IP spoofing relate to just a plain DOS attack?
Good question. It's an important distinction. In a sort of standard DOS attack, the main goal is just to overwhelm the system, stop it working.
Right.
They might not even spoof the IP. The packets might look legitimate, maybe even coming from the attacker's real IP, or just appearing authorized. The goal is simply to bombard the target with so much traffic that it crashes or can't respond to anyone else.
So spoofing is about deception, DOS is about brute force flooding?
Often, yes. Though they can be combined, like in the Smurf attack, that principle of defense in depth, having multiple layers of security, including encryption, is just vital against all these different attack vectors.
It really emphasizes that security isn't just one fix. Now, that other exemplar you mentioned, the one focused on analyzing network attacks, what insights does that one offer?
Right. That one looks at a scenario where a website starts timing out. Users can't connect.
Okay.
And by digging into the log file excerpts, the analysis in the exemplar identifies it as a probable denial of service attack. Specifically, a SYN flood.
SYN flood. Okay, what's that exactly? We mentioned DOS types, but...
Yeah, it's a specific type, yeah. It exploits how internet connections get started using TCP/IP, the three-way handshake.
The handshake.
Yeah. Your computer sends SYN packet to start. Server sends back a SYN ACK and reserves some resources. You send back an ACK to finish, connection's open.
Okay, standard stuff.
In a SYN flood, the attacker sends tons of SYN packets, but never sends that final ACK.
Oh.
So the server keeps reserving resources for all these half-open connections, waiting for ACKs that never come. Eventually, it runs out of resources and can't handle legitimate connection requests anymore. Hence the timeouts.
Like tying up all the phone lines at a call center with bogus calls.
Exactly like that. A perfect analogy.
So the exemplar shows how to spot those SYN packets without the final ACKs in the logs and then connect that to the website problems.
Precisely. It really stresses looking at the log data, explaining your reasoning why you think it's a SYN flood, documenting the impact, describing how the vulnerability was likely exploited, and how that led directly to the connection timeouts users saw.
So it's about evidence and explanation.
Exactly. The key takeaway isn't just what happened, but how you know. Real analysis means presenting evidence from logs and a clear, logical rationale. And it highlights that practicing recognizing these patterns makes you faster and better at incident response.
That sounds incredibly useful, seeing that process broken down. Finally, the information included a glossary. Always handy.
Absolutely. A good glossary helps solidify understanding. It defines those key terms we've touched on: active-passive sniffing, botnet, DOS-DDoS, ICMP flood, IP spoofing, on-path, ping of death, replay attack, Smurf attack, SYM flood, all that jargon. It's a useful reference.
Okay, so to wrap up this deep dive then, we've looked at the constant challenge of network attacks, focusing on methods like interception and backdoors. We've seen the very real consequences: financial, reputational, even public safety. We also touched on tools like TCP dump for investigation and looked at real examples like that 2016 DNS attack, plus how those exemplars help build analytical skills.
That's a great summary. And developing that ability to really analyze network traffic and logs, that's just a critical skill for any cybersecurity analyst. It's how you respond effectively and minimize damage. The exemplars are definitely good learning tools for that.
Right. And that brings us to our final thought for you, the listener. In this world that's just getting more and more connected, more reliant on networks, what are the sort of broader implications here, thinking about these attack methods, the constant need for vigilance, for learning? It really is a nonstop evolving landscape, isn't it? Something to definitely keep thinking about.